In this illustration, we intend to simulate the penetration of a projectile into an aluminum plate in the Abaqus software. In this example, the rigid projectile hits the aluminum plate with a high speed, and since the projectile moves at a very high speed, it penetrates the aluminum plate. The type of aluminum in this example is AA5083-H116. Here, the effect of temperature on deformation has been considered. To do so, the thermal properties of aluminum have been defined in the Abaqus software. This problem has been solved for different velocities of projectile. Actually, this problem is solved several times, and each time the velocity of projectile changes accordingly. In this picture, the impact velocity of projectile is equal to 286.4 meters per second. In the next picture, the impact velocity of projectile is equal to 303 meters per second. In this picture, the impact velocity of projectile is equal to 357 meters per second. The analysis is aimed at obtaining the final velocity of projectile, and in this diagram, the final velocity of projectile has been illustrated. Actually, the diagram having been drawn with red color is the one obtained from the Abaqus software. In this diagram, the residual velocity has been illustrated based on the initial velocity. In fact, we intend to simulate this article in the Abaqus software. The article is entitled Perforation of AA5083-H116 aluminum plates with conical nose steel projectiles experimental study. In these pictures, the way projectile hits the steel plate can be observed. I will enter the Abaqus software for simulation. I will click on Create Part. I intend to create geometric shape of projectile. I will select the modeling space as 3-dimensional. From here, select Analytical Rigid, then select Revolved Shell. Enter approximate size equal to 0.5 and continue. As explained in the article, the diameter of projectile is equal to 20 millimeters and its length is equal to 98 millimeters. In this picture, you can observe its geometry and size. Finally, I will click on Done. I will click on Tools menu, select Reference Point, and consider this point as the reference point of projectile. Click on Special menu, select Inertia and Create. Select Point Mass Inertia, continue. Select the reference point of projectile, done. As explained in the article, mass of projectile is equal to 0.197 kilograms. And OK. I'll click on Special menu, select Inertia and Create. Here select Heat Capacitance. Continue, select the reference point of projectile and done. I'll click on Create section. Select Solid, Homogeneous, Continue and OK. I'll click on Assign section, select Plate, done and OK. Select Velocity and Continue. I will select the reference point of projectile, done. The initial velocity of projectile is considered to be equal to 303 meters per second and OK. Here you can observe the parameter of temperature. The temperature increases up to 327 centigrade. In the next step, we intend to draw the diagram of the projectile's velocity. To do so, I'll click on Create XY Data, select ODB History Output and continue. Here I'll select V2 or the same projectile's velocity and click on Save As. Here you observe the diagram of the projectile's velocity. The initial velocity is 303 meters per second and the final velocity is 164.6 meters per second. Here, its quantities can be observed. As already mentioned, the initial or the same impact velocity is 303 meters per second, and the final velocity is 164.6 meters per second. As you see here in the article, the initial velocity is 303 meters per second and the final velocity is 160.8 meters per second. As you observe, the results obtained from the Abaqus software are very close to those mentioned in the article. I will save these quantities in the Excel file. In the next step, I will increase the projectile's velocity up to 357.3 meters per second. I will click on Result. Here we intend to draw the diagram, the projectile's velocity, as it can be observed here, the initial velocity is equal to 357.3 meters per second and the final velocity is equal to 247.47 meters per second. If we refer to the article, we will notice that the final velocity obtained from the article is equal to 251 meters per second and the final velocity is 247.47 meters per second. As you observe, the results obtained from the Abaqus software are similar to those mentioned in the article, or in other words, the results obtained from the Abaqus software are very close to experimental results. I will save these results in the Excel file. In the next step, I'll change the projectile's initial velocity to 286.4 meters per second. Here I'll draw the projectile's velocity. As you see, the projectile's initial velocity is equal to 286.4 meters per second, and its final velocity is 135 meters per second. As you observe in the article, the final velocity obtained from the article is equal to 126.4 meters per second, and the final velocity obtained from the Abaqus software is 135 meters per second. I will save these quantities in an Excel file. In the next step, we intend to draw this diagram in the Abaqus software. Here, the horizontal axis is initial velocity and the vertical axis is residual velocity. The diagram we intend to draw is for the plate with a thickness equal to 25 millimeters. The diagram drawn with red color is obtained from the Abaqus software. As you observe, the results obtained from the Abaqus software are similar to those mentioned in the article. Actually, the diagram we have drawn is related to a plate with a thickness of 25 millimeters, on which the horizontal axis is initial velocity and the vertical axis is final velocity. As you observe, the results obtained from the Abaqus software are similar to experimental results, indicating that this question has been simulated correctly in the Abaqus software.